Okay, let's do a reminder on how to do regressions. I have some data that I just made up here in a table. And to get started on any regression, whether it's linear, quadratic, or exponential, those are the three kinds we've done, we have to go to Home. So we click the Home On button and we go create a list and spreadsheet. So this one has to be done in the document. We cannot do it on the scratch pad. So you're going to use your arrows and navigate to this little grid looking one, hit enter, and it takes us to our spreadsheet. We're going to type in the data just like it is here. I'm going to use my keyboard rather than clicking these buttons. So we do 1, 2, 3, 4, 5, 6, 7, 8. And then we go to column 2, and we're going to put in those numbers there, 18, 14.4, 28.8, 57.6, 128, 281.6, 563.2, 921.6. In order to do a regression, our data has to have column names or headers. So we go up to where it says A and B, and then we have to give it a name. You can use a descriptive name, so you could use like time if this is our independent variable, and then hit enter, and you can do height. I don't know what these things are measuring. These are just arbitrary numbers I made up. You can also just use X and Y if you want to keep it simple. Then with the cursor highlighted in the white area, so move it down to the white, we're going to go to menu and then 4 for statistics, because regressions, lines of best fit, are a statistical calculation. So we're going to go to menu and then 4. And then within that, we want to do stat calculations. So we picked menu 4.1. All 3 of our regression types live in here. The 3 that we care about are linear regression, mx plus b. There's also linear regression, a plus bx, but we want this one so that it's giving us the equation as like a slope-intercept equation. Then we have quadratic, number 6. Don't get confused between quadratic and quartic. They look similar, but this one is the one we've done. So quadratic is the important one. Quartic would be like an x to the 4th equation. That's going to be quite different and will not get you the right answers if this is what you should be picking. So we have number 3, number 6, and letter A. Exponential regression is our last one. This function that I've made up should be exponential, so I'm going to click on that one. And then here I'm going to click with my finger on this button to bring up my drop down and then use my arrow. My X variable I named time. If you name it X and Y, then it'll be obvious. Otherwise, you need to know what you named each one. So we're going to pick time, arrow down, click here again, pick height, click there again. Once you've picked your 2 variables, we don't need to do anything else in here. We just hit enter in order to run the regression. So once I do that, I have my exponential regression here. I can use the arrows to go down and see my A and B term. Remember that exponential functions come in the form y equals A times B to the x power. I also get this R squared value. R squared and R tell us about how good this fit is. We didn't talk about those in terms of exponential and quadratic. We only talked about them for linear. But they're telling us how good of a fit this equation is for the data that we provided. Since this is 0.99, that's a very, very strong correlation. I made it that way so I knew that it would be really close. So this is a very good fit, that we have an equation that's pretty close to 3.7 times 2 to the x would be the equation we get. Now, if we want to graph that, something we may or may not have done. So say I wanted to know what is the predicted value when x equals 11. We need to go forward a little more. We have 2 options. One is write down this equation and plug in 11 for x. The better option, though, is to go back to home, and we actually have to make a graph document. This won't work on the scratch pad, so we're going to make a graph document with this little parabola here. And then it starts off at f2 of x, because f1 of x is our regression equation. So if we press the up arrow, it's going to take us to the previous function in our list, which is that one with that we got from the spreadsheet. Notice here that it has lots of decimals, so we're not really rounding at all. This is going to be a very, very precise version of the equation, whereas if you write it down, you're going to cut off a lot of the decimals, and it'll be not quite perfect. So once we find that equation, we hit enter to graph it, and this is what our equation looks like. Then, since this is a function, we can do Control T to bring up the table of values and scroll down to whatever x value we wanted. So we have an x value of 11. Our predicted y value based on this curve is 8,581.53. Again, you'll get a slightly different number, maybe off by some tens or hundreds if you plug in by hand instead of using this graph. Now, one other thing I want to look at for this, also to go between documents, you do Control and then this left or right button. So if I want to go back to my spreadsheet, I do Control and left. You can also use your finger on the mouse cursor and move it up to here and click on the tab that you want to go to. So I also want to show you that we can actually do all three types of regressions on the same data if we're not sure which one is the best fit. So let me go over here and I'm going to do menu for 1 again, but now instead of exponential regression, I'm going to pick quadratic regression. I'm still going to pick my time and height variables and hit OK. And now I have my quadratic regression and my exponential regression both in this table. I'm going to go ahead one more time over to here and I'm going to do menu for 1 and then 3 to do a linear regression as well based on my time and my height. So now I have all three, my linear regression with my slope and y-intercept, my quadratic regression with my a, b, and c for my coefficients of ax squared plus bx plus c, and my exponential regression with my a and b value. But what I want to look at here is my r squared value. So r squared here is 0.997. That means it's a very, very good fit. So this is probably best modeled as an exponential function. If I go over to my quadratic section and find its r squared value, it's 0.985. So it's also actually a very good fit for the data that I've put in, but not quite as good, but it's close. Then if I go to linear, we'll see that the r squared is only 0.77, so it is not as strong of a fit because it doesn't really follow this pattern of the data that I've put in. So if we ever want to compare the different regressions, we can look at their r squared value and see how they line up. So that's our review for regressions of all three kinds. It's just about knowing where to put in the data and what buttons to press. And then if you need to plug in an x or y value, going to the graph is really helpful for that. So now even if I wanted to add my other functions in here, I'm now at f4 of x. So if I wanted to graph my quadratic regression, it would look like that. And notice it's a very different graph, but within the region that I'm looking at, right, within the data that I put in, these two must both be pretty close to what was modeled. And then if I want to do my linear one as well, I can do that one there. So within the region, I think we're talking about like up here, they all get kind of close together for a while. So then if I wanted to look up my table values for any of those, I have them all right here, and I can find a y value and a matching x or vice versa. Okay, so that covers regressions.